Okay, so here we have Alex and Fatima both randomly guessing all the answers. Because there's a 4-question true or false, right? So they're either correct or incorrect. And because it's only 2 choices, if they randomly guess, half the time they should be correct. They guess correctly, and half the time they guess it incorrectly, okay? So because their guesses are random, each question has an equal chance. That's what I just said, okay? After the quiz, they try to predict their grades. Because each response has an equal chance of being correct or incorrect, Fatima thinks, or Fatima, I think it's Fatima, thinks that the probability of getting all correct answers by guessing is equal to the probability of getting exactly 1 correct answer by guessing. Alex disagrees. He thinks that the probability of getting exactly 1 correct answer is greater. So let's find out. So how would we do this? Okay, based on the sample space of possible outcomes listed below, where C represents a correct answer and I represents an incorrect answer, who is correct, Alex and Fatima, or Fatima? Okay, so let's use what we just learned about set theory, okay, and we'll see how we can do this, okay? So let's define what Fatima thinks as A, okay? So we'll say that A is equal to Fatima, which means she thinks all correct. Now, rather than draw a bunch of circles, I'm just going to put a red dot next to any of them that meet what she predicted. So, are any of these all correct? No, they all have at least 1 incorrect. See, I stands for incorrect, C is correct. This is the only one that fits in set A. So remember, the probability of A is given as the number of elements in A over the number of elements in the set, right? And that's equal to, we have 1 in A, and there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There are 16, so we have 1 out of 16. So that's the probability that you could guess them all 100% correctly. Okay, now let's do B, and we'll pick a different color here. So let's do B. So B we're going to define as getting 1 correct, because that's what Alex said, if I remember right. 1 correct. Alright, and let's just double check that. He thinks probably getting exactly 1. Now that means you can't get more than 1. You have to get exactly 1 correct. So only exactly 1 correct. So this does not have 1 correct. This has not that has 3 correct. It's not count. This has 1 correct. Exactly. That does not. Has 2 correct. That has 3 correct. 0 correct. There is 1 correct. There's 2, 3. There is 1 correct. There's 2, there's 2, there's 3. There is 1 correct. There's 2 and there's 2. So the probability of B is equal to the number of elements in B over the number of elements in the space. And that's equal to, there were 1, 2, 3, 4. Over 16, and that reduces to 1 over 4. So which number is greater, 1 over 16 or 1 over 4? Well, you can do your 1 divided by 16 here, and that number is 0.0625. And you can do 1 divided by 4 here, and which of these numbers is greater? I'd rather have 25 cents than 6 1/4 cents. So it is true that B, Alex, is correct. Okay, let's try another one of these. Alright, so Harry Potter's at Ollivander's wand shop. Oh boy. As we all know, the wand must choose the wizard. Harry cannot make the choice, and he interprets wand selection as a random process. You can compare probability. The wood types available are holly, elm, maple, and wenge. Core materials on offer are phoenix feather, unicorn hair, dragon scale, raven feather, and thestral tail. Based on the sample space of possible outcomes listed below, what is more likely, that the wand that selects Harry is made of holly and unicorn hair, or that the wand is made of holly or unicorn hair? So we'll do A, So again, we're going to define A as holly and unicorn. So see, when I do these problems, I start out by just writing out and defining what they are. And B, we're going to call B. Okay, what's going on here? Oh boy. All right, let's try this again. Or maybe write it over here. B, we will say, is equal to, B was equal to holly or unicorn. So this is the intersection of holly and unicorn. And this is either holly or unicorn. Okay, so let's do we may as well do B first. So B is everything holly, which is right here. This is all the hollies. Okay, I'm going to circle that set. They're in B, right? As is everything in the unicorn. Because we're going to say everything that's one or the other. Okay, so we end up with 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 out of a total. There's going to be 1, 2, 3, 4, 5, 6, 7, 8 out of, and there's going to be 20. 8 out of 20. In B, let's do A. So A is going to be likely of, oh, wait a minute. Sorry. Okay, we call B a holly or unicorn. So that is holly or unicorn, and that's 8 out of 20. A, we said, was holly and unicorn. So it had, this is not holly and unicorn. These are not holly and unicorn. Those are not holly and unicorn. The only one that is A is the intersection of these two things, right? The intersection, so that would be 1 out of 20. So what is the probability that is greater? The one that is more likely to be made of holly or unicorn, or the holly and unicorn? The answer is holly or unicorn. Okay. Try another one. I didn't like that one at all. At a sandwich shop, choose from white or rye. So we have a choice in breads of white or rye. You can see there. Turkey or ham. So there we have turkeys and hams. Turkey and ham with white. Turkey and ham with rye. And Swiss or American cheese. So Swiss with turkey and white. Okay, so there we have our bread, meat, and cheese. So we got a sample set here. It's got all of the different sandwiches, 8 different sandwiches that exist. All 8 possible sandwiches are down there. If we take outcomes 2 and 6 as a subset of the sample space, which of the options describe this subset? All right, so let's circle 2 and 6, and they're already highlighted in red. So there is 2, and there is 6. So what do they represent? Well, they represent, what do they have in common? They have, the bread is not in common, but their Turkey-American combination. Turkey-American combination is what they have in common. And none of the other ones have Turkey-American as a combination. This is Turkey, but not American. This is American, but not Turkey, etc. Turkey, not American. American, not Turkey. So the subset is composed only of all the outcomes where the sandwich has white bread. That's not true. These are white, and it's not included. The subset is composed only of all the outcomes where the sandwich has ham. That's not true, because here we see some that are not part of the subset. Only of all the outcomes the sandwich does not have ham and does not have Swiss. Aha! No ham, no Swiss. Now, and it says and does not have Swiss. So that means if it's not having ham, it has to have turkey. If it's not having Swiss, it has to have American. So if it's not ham or Swiss, then it must be turkey and American. That one looks right. Subset is composed only of all the outcomes where the turkey has turkey and American cheese. Oh, wait a minute. That sounds like it's also correct. I've got turkey and American here, turkey and American there. So turkey and American, that looks correct there, right? Turkey and American looks correct. This one says not ham, which would take, let's get rid of those that are not ham real quick. So that would get rid of this one, and this one, and this one. Oops, that one won't erase. Okay, I don't know what happened. I don't understand this. For whatever reason, doesn't want me to erase those two, but it's going to get rid of those two bottom ones. And not ham and not Swiss, so that would get rid of this guy and this guy. So yeah, that one is actually true, and so is this one. So we've got both of those two, and we check it there, and then we're doing pretty good. So that's how these are done. I'll let you work on the rest on your own.